Okay, we're going to keep looking at sequences today. Given an infinite sequence where the limit as n goes to infinity of the a sub n term equals L, the real number, then we say that sequence is convergent. The places where you're going to see that that doesn't work, or where you end up with divergent, is there's two main types. If your limit ends up going to either positive or negative infinity, then that limit does not exist and it would be divergent. So that would be what we're talking about here. An example would just be if your sequence was just n here, where it's just the numbers increasing. So if you did limit, so the a sub n term here would just be n. If you did the limit of that one, that's just going to approach infinity, so this one would be divergent. The other main type is if your sequence oscillates, or there's oscillation going on. So an example, if you just had this series that went back and forth between 1 and 2, it's not approaching anything, so that one would also be divergent. All right, so let's look at some more examples. Determine whether this sequence is convergent or divergent. Well, this one it has cosine in there. Recall cosine, that's one of those graphs that's going to be oscillating here. And we know that cosine always is going to oscillate between, we had a graph here, it's always going to oscillate between 1 and negative 1. So this one might be a good one to, if you go back to some of the limit stuff you learned early on, might be a good one to do this one by looking at the cosine. That cosine of n we know is always between 1 and negative 1. And I think we can use something called squeeze theorem to check this one out. So if we know that's true, let's get that other stuff in there now. So what if we now added that 2 in there? So if we did 2 plus in here, that means if we add 2 to the inside, we got to add 2 to the outside here too. So if we added 2 out here, this is now 3. If we add 2 out here, this is now going to be 1. And we also want to divide by n. So if we, like here we added 2. Let's now divide by n. So now if we do that and take the limit of this, this ends up being, what's the limit? As n goes to infinity of basically the stuff we have over there besides the square root sign. Here this is going to be, what's the limit? As n goes to infinity of 3 over n. And over here we got, what's the limit? N goes to infinity of 1 over n. Well, we don't know the middle one, but the two outside ones we surely know. Those two outside limits are both going to approach 0. So this is 0, this is 0. Well, you can't be both greater than or equal to 0, so then what we can say is by squeeze theorem, we know this limit approaches 0. So the limit as n goes to infinity of 2 plus cosine of n over n has to equal 0. All right, so now we can figure out this this one up here now. So limit as we approach infinity of this function should be, we got that square root over this, should be the same thing then as the square root of the limit as n goes to infinity of this. Well, by squeeze theorem, we just figured out that all of this ends up equaling 0. And so then this is going to be square root of 0, which still is 0. So this one is convergent. So this would be an example of a convergent one. With that kind of had a function around there, but you'd evaluate it using squeeze theorem. All right, let's look at this one. what's this limit going to be here as we go to infinity? Well, um, as we go to infinity here, marker's not working very well. Let's try again. Limit as n goes to infinity of n cubed over this. All right, so this one, if we were to put infinity in there, infinity cubed is definitely infinity. E to the infinity over 10, well, that's e to a big number. That's when I get an e to a power that's very large, that's also going to be infinity. It looks like this one is one of those indeterminate ones here. And so what do you use on limits that are indeterminate? Yeah, L'Hopital's. So this is a L'Hopital's one. So let's see what we get here. So if we do derivative of the top, that's going to be 3n squared. On the bottom here, what's the derivative of that one? We're going to have to use chain rule to do that derivative. So the derivative of the outside part would be the same, e to the n over 10. Derivative of the inside part, though, n over 10, you can kind of think of as 1/10 n. So that derivative would be 1/10. So there'd be a 1/10 out here. All right, so what is the derivative of that? Or sorry, what is this going to approach? This is going to infinity still. Bottom, just because we got that 1/10 of infinity, still giant number here. So this is still in infinity over infinity. Looks like, again, we're going to have to use L'Hopital's another time here. So let's take derivatives again. So now on top we got 6n. On bottom, derivative of that would be, again, using chain rule, but we'd have kind of like a 1/10 times another 1/10 here when we do chain rule, meaning this would be 1 over 100 now. Still going to be very large, and the top is still, 6 times infinity is still going to be infinity. So it looks like, again, use L'Hopital's here. So let's use L'Hopital's another time. And I think this time we're going to get to where we want here. Derivative of the top is 6. The derivative of the bottom, using chain rule again, there's going to be another 1 over 10. So this is going to be 1 over 1,000 now. E to n over 10. But still, as you're going to infinity, that bottom's still going to be very large. But the top's now 6. So if we have 6 over a giant number, that's going to approach 0. So this limit is converging or convergent, and it's approaching 0. So sometimes remember, if you get those infinity over infinities or an indeterminate form, use L'Hopital's. Determine whether this sequence here is convergent or divergent. So this one, you got, it looks like if we write this limit out, you get 2n plus 3 over 5n minus 17. So this is infinity over infinity. You could definitely use L'Hopital's. This one, though, is one of those we've looked at in the past too. You could just use some multiplication. Biggest power in the denominator is 1, so if we multiply by 1 over n to both top and bottom, this now is going to be 2 plus 3 over n. On bottom, we got 5 minus 17 over n if we distribute that out. And we know the two terms over n are both going to 0. So this would be 2 plus 0 over 5 minus 0, or just 2/5. And so this one is converging to the value of 2/5. All right, next one, determine whether this one is, again, convergent or divergent. We want to do the limit of this. So what is the limit here as n goes to infinity of 3 times the inverse sine of the square root of 3n minus 1 over 4n minus 1. Well, this one is going to be There's no ends with that 3 sine inverse, so that's kind of like a function in front. So when you have those function ones, remember, what we can do is just look at this. What's 3 times sine inverse of the square root of, here's the real limit part we're looking at now. What is this limit going to approach? Well, that one's very similar to the last one we just did. We know that one, if we multiply by 1 over n, is going to just end up approaching, looks like 3/4 here. So if we multiply by our 1 over n and 1 over n, now we got limit then goes to infinity of just this. And that's going to approach 3/4. So now that we know that that limit approaches 3/4, now we can just evaluate this function at what we know the limit approaches. So what is the 3 inverse sine of 3/4? Well, one thing we could do here is you could write 3/4 as, or take the square root of both of those. So we'd have square root of 3 on top, and on bottom square root of 4 is 2. So what's inverse? I forgot the inverse on there. What's inverse sine of square root of 3 over 2? Inverse sine of square root of 3 over 2. That one, it would be one they could expect you to do without a calculator here. So think back to your unit circle. All right, so square root 3 over 2. What angle produces that? And remember, sine value, it's a y value here. So which one gives us that? Well, I think that's when we are dealing with a unit circle here, where we have a 60-degree angle, because we know a unit circle hypotenuse is 1. This cosine value, or the x value, is half, and this longer leg is square root 3 over 2. Then that would be our sine value. So that happens when you have a 60-degree angle. Well, what's 60 degrees in radians? Remember, we want to multiply by pi over 180. So that would be 60 pi over 180, or just pi over 3. So it looks like the radian value of that would be pi over 3. And so if we simplify that, looks like this one does just end up equaling pi. So it's convergent. It would be convergent to pi.